A circular disk has non-uniform surface charge density, decreasing linearly with distance from the center. We need the ratio of flux through a large sphere to flux through a smaller concentric sphere of radius R by 4. Let us solve step by step. By Gauss' law, flux through any closed surface depends only on the charge enclosed. So the ratio of fluxes will be the ratio of enclosed charges. Take a thin circular ring of radius r. Its area is proportional to 2 pi r dr, so after adding all rings up to radius a, we get this charge formula. The large sphere encloses the full disk, so put a equal to capital R. This gives the total charge on the disk. The smaller sphere cuts the disk in a circular region of radius R by 4. So it encloses only the charge lying within that central region. The epsilon 0 factor cancels out, along with pi, sigma 0, and capital R squared. The required ratio is 32 by 5, which is 6.4. Therefore, the ratio of the two fluxes is 6.4. For more clear step-by-step exam solutions, keep learning with Acharya.